Welcome to the Ultrasonic Sensing video training series. My name is Akeem Whitehead, an applications engineer with Texas Instruments. Because this is the first video of the series, I will first introduce and provide an overview of what ultrasonic sensing is.
What is an ultrasonic sensor system used for? An ultrasonic sensor system can be used to detect the presence of objects, measure the distance to objects, and track the position or movement of objects. This is all made possible using a principle called time of flight, or TOF, which is a method for measuring distance between a sensor and an object. An ultrasonic TOF measurement usually consists of the following steps. First, an ultrasonic sensor converts an electrical signal to a mechanical vibration. This mechanical vibration emits a pulse of ultrasound energy to traverse through a transmission medium, such as air or water. Second, the ultrasound energy traverses through the transmission medium at the speed of sound until it reaches an object. Third, the ultrasound energy is reflected off the object and traverses back in a direction towards the sensor. Fourth, once the ultrasound energy reaches the sensor converts the received mechanical vibrations back into an electrical signal for amplification and post-processing by integrated circuitry to calculate the time of flight. What is an ultrasonic transducer? The ultrasonic sensor is called the transducer for its ability to both convert electrical signals into mechanical vibrations and mechanical vibrations into electrical signals. Selecting the appropriate transducer is important for the ultrasonic system because not all transducers perform the same. Transducer parameters such as operating frequency and size will determine the minimum and maximum detectable range, field of view, and accuracy of the sensor. What are some real-world applications where ultrasonic sensing is used? Ultrasonic sensor systems are used in a variety of applications, from automotive vehicles for reverse park assistance, autonomous robotic navigation for collision avoidance, and unmanned aerial vehicles for landing assistance, to factory automation purposes such as object counting, liquid level sensing, and defect detection. What is the advantage of using ultrasonic sensing? Ultrasound is often preferred over similar sensing counterparts such as infrared sensing or optical sensing because the ultrasonic transducer is less susceptible to performance loss or damage typically caused by debris, dirt, dust, temperature changes, or exposure to water. What is the disadvantage of using ultrasonic sensing? Ultrasonic sensing's primary limitation is its inability to effectively detect objects that are similar in acoustic impedance as the transmission medium. For example, if the ultrasound energy is traversing through air and the object is very soft, such as polyurethane foam, a sheet of wool, or a high-pile carpet, then the majority of the ultrasound energy will pass through, be absorbed, or scattered by these objects. Ultrasonic sensing works best when detecting large, hard-surfaced objects to maximize the amount of ultrasound energy returned towards the sensor. This video series will discuss the physics of ultrasound, how to properly select the transducer, how to optimize driver and receiver settings, and how to integrate a single or multiple ultrasonic modules into a system. The targeted applications in this video series are for air-coupled or liquid-coupled ultrasonic sensing using transducers ranging from 20 kHz up to 1 MHz. This video series does not cover the requirements for medical ultrasound, ultrasonic flow metering, or solid-coupled applications.
With this collective knowledge of how an ultrasonic sensing system works, you'll be able to start evaluating TI's ultrasonic sensing devices, move to small form factor prototypes or special case prototypes, and finally mass production of the modules that will go into your end equipment.